So what would y equals minus f at x will look like? It should be, right? This is f at x in terms of transformation reflected on the x-axis, right? So it's going to look roughly like this. Okay, let's show it algebraically. It's just f at x, which is root of x plus 2 plus 3, and just multiply the whole thing by negative. Okay. Right, when you distribute, this becomes negative 3 as well. So note that now we start from negative 2 and negative 3. Okay, so indeed this is the graph. What if we put y equals f at negative x? Well, that should be this graph here reflected on the y-axis. So it will look like this. Okay, so let's show that. It's root of the x replaced with negative x. Okay, so root of the factor out of negative, you get x minus 2 plus 3. And note that if I plug in 2 in here, it becomes a 0, so you get 3. So we have 2 and 3. We put 1 in here, you get 1. The root of 1 is 1, plus 3 is 4. So we do get 1 and 4. Okay, so it does validate that the red graph, in other words, it's a reflection on the y-axis. Lastly, negative of negative input of x. So from the black graph, this is going to be a reflection on x as well as y-axis. So negative of root of this right here, this thing right here. Okay, if you distribute the negative, you get negative root of negative x minus 2, okay, negative 3. So it's going to be this reflected on the, right, on the y-axis. Right, so this negative 2, negative 3, it'll become a 2, negative 3. Okay, so it's, right, and negative 1 and 4, negative 4 will become 1 and 4. So it will look like that instead. That's the final graph.